6 is on concavity in the second derivative test. So I tried to find like a little clip art that has a good indication of what concavity is. So the definition is that the slopes of all the tangent lines are decreasing in value, and the slopes of all the tangent lines are increasing in value, which is very confusing. So like I've told you guys before, I kind of sketched this out before, I think. If you have a curve where it's open like a bowl, like something could kind of lay in that bowl, that's concave up, okay? So that's up. I guess I should point out. Down, down, up. Do you guys see it? Down, like that, okay? And if you did draw in all the tangent lines, when something's concave down, all of those tangent lines are getting, like as you go from the left to the right, they're getting less steep, okay? And even over here, like they're continuing to be more negative, more negative, more negative, okay? So you guys kind of have that sketch to help you out. Does that make sense? You guys get it? All right, so definitions of concave up and concave down. It says if f double prime of x is greater than 0 for all of the x values in an interval, then the graph of f is concave up. So f double prime is positive, concave up. F double prime is negative, means concave down. An inflection point is where the concavity changes. So looking back at that sketch that I did here, it would be like right in here would be a point of inflection, or inflection point as we call them. Do you guys see those? Okay. All right, so it says determine where the graph of f is concave up, concave down, find any inflection points and draw a graph. So as we find f prime, because we have to find f prime before we can go straight to f double prime, right? So we're going to do 4x cubed minus 12x and then plus 0. And then f double prime is going to be 12x squared minus 12. So if I set the second derivative equal to 0 to find the critical values, they are no longer called critical values now. Critical values were for first derivatives. So we call these points of interest, right? Think of inflection points, IP, points of interest, PI. All right, and we break it apart. So we get points of interest of -1 and 1. I will still sometimes call them critical values. And we do an f double prime number line. So we have -1 and we have 1. And we're going to test in f double prime. So that's why I was very specific on those previous ones, and I always wrote f prime next to the little number line, because I knew that I was going to eventually do f double prime. So f double prime, when I plug in -2 into the second derivative, so in right here, I get that I have 12 times a negative number times a negative number would be a positive number. And if I plug in 0, I get positive, positive, negative is negative. And if I plug in positive, positive 2, I get positive, positive, positive is positive. So I no longer do up, down, up. I want to show concavity. So what I do instead is concave up, right? I don't do arrows on the end. Concave up, concave down, concave up. Make sense? So think about what this graph would look like. Does it make sense? If I had up and then down and then up, does it make sense based on the original? Yeah, it's one of those W curves, right? Whenever we have x to the fourth minus an x squared, it's always a W. All right, so our inflection points are going to be, they're very specific. It's never necessarily where the second derivative is equal to 0. That's not necessarily where an inflection point is, and I can show you an example of that. But it's where our concavity, where we change from concave up to concave down or concave down to concave up. So where the second derivative changes sign. So where would our inflection points be in this case? -1 and 1. So we want to find where the actual point is. So we go back to our original and plug in -1 and 1. So when I plug in -1, I get -1 to the fourth minus 6 times -1 squared plus 1. So I get 1 minus 6 plus 1. So I get -4. And if I plug in 1, do you guys see I get exactly the same thing? It's an even function, so we get -4 as well. So inflection points are going to be at -1, -4, and 1, -4. And the reason on your AP test is always f double prime changes sign. So if you want to write yourself a little note, f double prime changes sign. That's why. And then where it's concave up and concave down, it's concave up from negative infinity to negative 1, and also from 1 to infinity, and it's concave down in between negative 1 to 1. Easy. We got this section down already. First example. I think you can handle it. All right. Yeah, I guess I did say draw a graph, didn't I? So if you're drawing a graph, we're going to have negative 1 comma negative 4. 1, 2, 3, 4. 1 comma negative 4. That's where it's changing from concave up to concave down. What if I wanted to find other things, like a max or a min? What would I do? I'd have to do the f prime, right? So I'd have to factor this f prime. So I'd pull out a 4x. I'd have x squared minus 3. So it'd be at plus or minus root 3. That would be the max and mins. And you could plug them back in to find the y values. We don't have to sketch a graph on this one. I shouldn't have said that on this one, but I think we're good. We're going to put all this together, and we're going to do all of these things eventually, but this is where it's changing from concave up to concave down. All right, we'll do another one. So number 2, so it says sketch a graph of the curve, labeling all points of inflection and extrema, so maxes and mins. So we're going to do everything on this one. Okay, so I'm going to do y prime, and it's going to be 4x cubed minus 12x squared. So let's find the critical values. So I'm going to pull out a 4x squared. When I do, I have x minus 3 left. So I get critical points of 0 and 3. So I'm going to put 0 and 3 on my number line, and I'm going to test y prime. So I'm going to test negative 1. Negative 1 gives me a positive on the outside because it's squared anyway, right? And then negative 1 minus 3 is negative, so I get a negative. If I try 1, I get positive times negative is negative. And if I try 4, I get positive times positive is positive. So I'm going down, down, up. Does it make sense based on our original? Yeah, it was x to the 4th, so my end behavior, both of them are pointing upwards, right, on the ends. All right, then I find y double prime. Yeah. Because this was only the first derivative. Now we're going to do the second. Yep, so we're going to do both. So I'm going to have the second derivative is going to be 12x squared, because I'm going from this first derivative right here, 12x squared minus 24x. I pull out the common factor, 12x. I have x minus 2 left. So when I set it equal to 0, I get 0 and 2. So now I'm testing in y double prime. So if I try negative 1, I get negative times negative is positive. If I try 1, I get positive times negative is negative. If I try 3, I get positive times positive is positive. So now this is where we go concave up, concave down, concave up. So we're going to do a big graph. And I want to label all points of inflection and extrema, so I want to find the y values. So I never called this like f of x, so I don't want to like on the AP test say f of 2, f of 1, f of whatever, because I never defined f. So I'm going to do y. So I'm going to say y of 0 and y of 3. I want to find those. So go back to our original. When I plug in 0, I get 0. When I plug in 3, I get 81 minus 4 times 27. Is that negative 27? Do you guys know how I did that? That was sneaky, wasn't it? I pulled out a 27, and I thought, oh, that would be negative 3. That would be 3 minus 4 then. Sneaky, huh? All right. Anyway, so I have 0, 0, and then I have 3, negative 27, 1, 2, 3, and then way down here at negative 27. And what will those be? So what's 0, 0? What's happening at that point? Show me with your fingers. Nope, it's 0, 0. It goes like this. It's like an x cubed, like a negative x cubed, because it's going down and then down again. So it's doing like one of these things. Minimum, right? Do you guys see? Because it goes down and then up, just like we talked about. So we're looking here, and then we're looking here. All right, and then what about these other points? We have 0 and 2. So 0, that was the point of inflection. How about 2? So y of 2 is going to be 2 to the 4th is 16 minus 4 times 8 is 32. So negative 16. What is that? Yeah, that's one of those inflection points, right? So that's where it's changing from down to up. So this is what our graph looks like. Oops, that's kind of weird. All right, so we have
Oh, wait, you already did y of 0, so you didn't need to do it again. And you plug it in all just to original.
Yeah, it's closer to it's over here if I really wanted to draw it accurately. What if I wanted to find where it crossed the x-axis? What would I do to find that? Yeah, I'd find the zeros by going back into our original, x to the 4th minus 4x cubed, pulling out the GCF, right, x cubed. I'd have x minus 4, so it actually crosses right here at 4. But I didn't ask for that. I just asked for the extrema. So it says label everything, so we're going to label. So we have an inflection point, or point of inflection if you want to write PI, at 0, 0. We have a inflection point, or point of inflection, at negative, not negative 16, sorry, 2 comma negative 16. And we have a minimum. Is it local, absolute? What do we have? Absolute, so local and absolute at 3 comma negative 27. Mm-hmm.
So the point of inflection is when it switches from down to up, and why does that not switch?
It does switch. So here's up. Do you see it? Here's down. Oops. Here's up. So it curves. It does like that, and then it does downwards, and then it does upwards. Sorry, I didn't draw it very well. It's like this. Down. It's kind of hard to see the up. It's not like where there's a maximum or a minimum, right? It's where it's changing from concave down to concave up. Do you see it? So it's like down, curving downwards, and then curving upwards. Looks like that.
So why would it not change as the exact? Oh yeah.
It does change there. It's just kind of, you guys aren't used to the point of the, so like if I was drawing, so let me draw another one. If I'm drawing one of those big curves like I was talking about there, I have down until right around there, right? And then it's up until right around there. And then it's down until right around there. So it's not happening at like the maximums or minimums.
I don't understand the sign where it's changing from down, especially on that part. I kind of.
Well, that's what the second derivative does for it. It finds the exact location where it's changing from concave down to concave up. Mine, I'm just estimating on this one. But.
So we don't really even need to think about it. We just need to know that all this.
I mean, it should look like it on your graph. It changes from down to up on mine.
But
Yeah.
on all those points on our graph, that's where it's going to change.
It should, yeah. So it should look right on your graph when you draw it. All right, so f prime, so second derivative test. So sometimes we don't have like the original function. So the AP test likes to do this with like chart problems. So sometimes if we don't have the original, we use something called the second derivative test. So this will be important. So it says if f prime of c is equal to 0 and f double prime of c is greater than 0, then f has a blank at c. Okay, so if f prime is equal to 0, there's 3 possibilities. Max, min, there's also the place where it's like x cubed, right? Like that. Make sense? No, didn't I tell you that some people call it saddle points? It's not actually saddle point. In 3 dimensions, it would be a saddle point, but no, there's not a name. It's a critical value that is neither a max or a min. That's the official name. Yeah. Undefined would not, because undefined could be maxes or mins, right? But in this case, we're talking about where f prime is equal to 0, not f prime equals undefined. All right, so, and then f double prime of c is greater than 0. So, the slope tapers off to 0, and it's concave up or down? Up, right? So if we have concave up, and we have a slope of 0, what's happening there? Minimum. So then f has a local minimum at x equals c. And then if you have f prime of c is less than 0, that means we're concave down, right? So that would be a local maximum x equals c. So like I said, you'll often have like chart problems where you'll be finding these different things. Okay? So number 1, it says find the relative extrema for f of x equals negative 3x to the 5th plus 5x cubed using the second derivative test. Okay, so we're going to go ahead and find the first derivative and the second derivative. So I'm going to get negative 15x squared plus 15, sorry, negative 15x to the 4th. All right, who got me back there? Was it Natalie? I think I heard her first. Who was it? No. Oh, Olivia.
I said it, but to give someone else.
I know Olivia's feeling.
Yeah.
So negative 60x cubed plus 30x, like that. So we're going to use the first derivative to find the possibilities for maximums and minimums, right? So we're going to set it equal to 0. We're going to pull out the common factor, so I'm going to pull out a negative 15x squared. When I do that, I have x squared minus 1. So I get negative 15x squared times x plus 1 times x minus 1. So our possibilities for maxes and mins occur at 0, negative 1, and 1. So you can do the number line, you can plug into the original to find what our absolute max and mins are and all that, but you don't have to do the number line. So one thing that you could quickly do is you go to your second derivative and you plug in those possibilities. So if I plug in into the second derivative, if I plug in 0, I get 0. If I plug in negative 1, I get negative 60 times negative 1 plus 30 times negative 1. I get 30, right? And if I plug in 1, I get negative 60 plus 30 is negative 30. So let's think about what this means. If f double prime of negative 1 was 30, that means that we were concave up there. But we tapered off to a slope of 0. So what has to happen? There's a local min, right? Local min at x equals negative 1. If I wanted to find where the y value was, I would go back to our original and find the y value by plugging in negative 1. All right, what about if it's negative? Well, that means that we were concave down, right? But we had a slope of 0. So that means we have a local max at x equals 1. Because I'm using the second derivative test, the thing that's in that box there. So I said the second derivative was positive, that means you're concave up. So when you're concave up and you have a slope of 0, then it has to be a minimum. But if you're concave down and you have a slope of 0, that has to be a maximum. So what about f double prime of 0 equals 0? Yeah, we can't conclude what's happening there. We don't know. There could be a max, there could be a min. We don't know. Okay, so the second derivative test doesn't help us in that respect. So we don't know. So what would we have to do to find 0? We'd have to go back to our f prime chart, and we'd have to do all those points. So the second derivative test can be handy, but a lot of times we just do the number line anyway, because sometimes we have not conclusive, right? All right. So let's look at the chart. So this is where you would use that second derivative test. I don't know what happened to all my grid lines. I had the grid lines on my notes, but whatever. We'll go with it. So given the values below for x, f of x, f prime of x, and f double prime of x, answer each of the following. So identify all values where f has a relative minimum. So relative minimum, what do we need? We need f double prime to be what? Here's what a minimum looks like. F double prime has to be greater than 0. F prime has to be equal to 0. Okay, so let's look for it. So f prime is going to be 0, so here, here, and here. And then f double prime has to be greater than 0, so it's only happening there. Do you guys see it? So f has a relative minimum at x equals 3. Does everybody else get it? Is it just Katie right now? If it's just Katie, then I'll help you during 6. So, but basically, if you have F double prime is positive, that means you're concave up. So use your hand like this, concave up. And F prime is negative, or F prime is equal to 0. So it tapers off to a slope of 0. So it means a max or min. Yeah.
I have a question because on a previous problem, we found a min and max, but not where F prime equals 0. So this one F prime.
Yeah, we did find that F prime equals 0. We did that first. It's right here. So F prime of x equals 0. We found it off to the side here. So these are their possible maxes and mins. Right? 0, -1, and 1. And those are the numbers we plugged into F double prime. Okay, so that's what we did here. So we found the possibilities. We said, okay, F prime is equal to 0 at -1, at 3, and 7, right? 0, 0, and 0. And then we looked to see where it was concave up or concave down. Okay? All right, at x equals 3. All right, so B, identify all x values where f has a relative maximum. So where would it have a relative maximum? Well, in that case, we need f double prime to be less than 0. We need it to be concave down. And we need f prime to equal 0. So where is it less than 0? At -1. So f has a relative max at x equals -1. Okay, so then this was the one that we are not sure about, the 0 right there, right? So let's think about things on the left and the right of it. So if we have f prime, and we were trying to test 7, okay, we want points on the left and the right, so like 5 and 10. Is f prime positive, negative? What is f prime at 5 and f prime at 10? They're both positive, right? So what's happening at 7 then? If you go up and then you go up again. Yeah, it's the thing where it goes like this. Okay, so that is actually neither in that case. So 0 is neither. And you would probably need to show that on your AP test. Like it would say, justify your answer, right? See how it says justify? So you would need to say f prime of 5 is greater than 0 and f prime of 10 is greater than 0. Therefore, there's neither at x equals 7. All right, does it make sense, though, how you see the charts, why you would have to know the second derivative test? All right, they like the chart problems. They're all over the AP test. All right, and then did I skip a C? Is there a part C? All right, identify all x values where f has a point of inflection. So point of inflection, in order to have a point of inflection, we need f double prime to change sign. We always memorize that. F double prime changes sign. So where does f double prime changes sign? Change sign. So we look at our chart. We look at our f double prime, and we're like, okay, we went from negative, negative to 0 to positive. It's right there. It changes at 1. Positive, positive, 0, positive. So even though f double prime is equal to 0 there, is that a point of inflection? No, because it went from concave up to concave up. Okay? So there's only a point of inflection at x equals 1. All right, and then what is the equation, the tangent line to the curve y equals f of x at x equals 5? So what do I need for the tangent line equation? I need 5 comma something, I need the point, and I need the slope. So my slope is going to be whatever f prime of 5 is. How do I get the point? Right, I just go back and I look for my f of 5. So it's going to be 3. So I have 5 comma 3 as the point. And then my slope is going to be what? 2. Yep. So I'm going to have 5 comma 3. And then I'm going to have f prime of 5 is 2. So I do y minus 3 equals 2 times x minus 5, like that.
How do you find the 3?
How did I find the derivative? I looked at my chart.
3.
I looked, so I went to 5. Here's the column for 5. And I have f of 5 is 3. The x value is 5. And then f prime of 5 is 2. So I'm looking for all those values. All right, and then sketch a graph of the function f having the given characteristics. So it gives me a couple points. It says that I have the point 2 comma 0 and I have the point 4 comma 0. Do you guys see that? F of 2 is equal to 0 and f of 4 is equal to 0. So those are my x-intercepts. It says f prime is greater than 0 if x is less than 3, f prime of 3 does not exist, and f prime is less than 0 for x is greater than 3. So this is where, whenever I have something like this, like on an AP practice problem, I would put 3 on my number line for f prime. I would say when I'm smaller than 3, f prime is positive. When I'm less than, or when I'm greater than 3, f prime is negative, right? So what does that mean for my graph? I'm going up, and I'm going down for the graph of f of x. But it did say f prime of 3 is it equal to 0? No, it's undefined, so there's something weird going on there. Yeah, so it could be a couple different things. You could have a vertical asymptote, you could have a corner or cusp, right? And then the next one deals with f double prime, and it says that f double prime is always positive except at 3. We don't know what happens at 3. So it's concave up, and it's concave up. So it could be a couple different things here. It could be a cusp, where it goes like this, up, and then up. Or it could be an asymptote at 3, where it's up, and then up. It doesn't matter which one you do. You can do either one. So let's say we make it an asymptote. Then it's going to be concave up and increasing, concave up, and you see how this is decreasing as I move from left to right? It's going downwards. So what if I said, in the original, what if I said f is a continuous function? Then that would be the cusp one. Does that make sense? There's lots of different possibilities.
So when you say sketch D graph, are there multiple ways?
There could be more than one, yeah. I think I have that on your study guide too. All right, and then the last thing I'm going to talk about is the weird thing with the second derivative. So this is why we always say, so why do we need f double prime changes sign? I shouldn't put that in quotes. It's kind of weird. F double prime changes sign. So why do I always use that as my justification for concave, for a point of inflection? Okay, here's why. Remember I told you x to the fourth is a weird graph in IP Calc? It's one that you should always kind of keep in your back pocket. Here's why. When I take the first derivative, I get 4x cubed. When I take the second derivative, I get 12x squared. That means I have a point of interest of x equals 0. And when I put 0 on my number line and I test in the left and the right, if I plug -1 into the second derivative, what do I get, positive or negative? Positive. If I plug in 1 into the second derivative, positive or negative? Positive. What does x to the fourth look like? It looks like x squared, kind of. Not really a w because there's no minus x squared part. It looks like this. So it's always concave up. It never changed to concave down. That 0 is just a minimum. There was no point of inflection there. So sometimes there's things that look like they should be a point of inflection because it's like, but the f prime is equal to 0 there. But it's not. It has nothing to do with point of inflection. Okay. So that's why you always need for your justification f double prime changes sign. Does that make sense? All right. Pass out your homework.